So working with Lidar data. So basically, we can do all these other things with point clouds, but this was an interesting application of actually starting to move up the value chain and add some other kinds of analysis or extract some value out. So you can see here the whole workflow, but basically we've got 9 gig of input files. We want to basically determine or highlight areas where Mark should actually be the guy doing this. I'm going to be looking at you to see if I'm right or not, but I think we're trying to find out the places where the trees or vegetation has grown above some thresholds. So we're going to basically go and chop the whole point cloud up in all little pieces. Within each piece, figure out what the vegetation height is in that piece, and then color those cells ultimately afterwards. And so if I go here and look, with any luck at all, I have the workspace here. And I ran this earlier because it does take about 4 minutes to grind this whole thing. But here's where the magic happens. We take the data, first of all, and tile it into 10 by 10 pieces. Then we go and we run it through a point cloud classifier. And is this thing on the FME store, Mark, or is it your own? It is, yeah. So basically this will filter the point cloud according to the LAS standard classification codes. And so basically I'm chucking out everything other than classification code 2, which is the ground, and 5, which is the highest vegetation. So I've thrown away everything else. And now once I've done that, I basically have itty-bitty little point clouds, one for every tile, that have in them the ground and the highest. And so now all we do is grab the bounds in X and Y. That gives me the kind of rectangle on the ground. And then secondly, we grab the bounds to get the Z high and Z min and Z max. And so with that, I've got the cube basically. And now here I get the delta, which is the Z diff, which is the max minus the min. And then we throw it out here. And so this is the output of the whole thing. In the back is the point cloud, so we can start to flip some stuff off and on. There's the original point cloud, and here is our canopy that we calculated. And if I zoom in somewhere here like this, oh, it may take a second. I may regret having done that. Anyway, now it's got basically, my problem is that I'm looking at the point cloud, and the data inspector is grabbing that. But if I click on there, in a minute, these purple ones, I believe, are the highest, right, Mark? And you'll be able to see that. Yeah, I do regret doing that. So it's got a basic, oh, there we go. Okay, so here we go, and you see that the diff is 27 meters, and that was enough to be highlighted. So that's an interesting example. In very few, it would meet the Don Murray test pretty much, this workspace. Not many more than 10 transformers to wring some good value out of a Lidar scan, and then highlight areas where we may want to go and look at the trees and, I guess, chop them down. What could be more green than that? So let's go on.